Hello deep learners, I am Shayan and welcome to Tec4Tric. In this video, I am going to build a simple convolutional neural network to classify the images from CIFAR10 dataset. So let's have a quick look on the dataset first and then we'll build the neural network. But before doing that, please subscribe to this channel and don't forget to click the bell icon. So let's get started. So here is our dataset. The CIFAR10 dataset, 10 means 10 classes. So the CIFAR10 dataset has 60,000 of 32 by 32 color images, that means RGB or red, green and blue in 10 classes. So these are the classes, that is airplane, automobile, bird, cat, deer, dog, frog, horse, sheep and truck, with 6,000 images per classes and they are randomly selected. Okay, so there are 50,000 images for training and 10,000 for testing. Here is the Google Colab notebook. This notebook has been shared with you. Please check the description box below. So first what I'm going to do is I'm going to import the packages. Okay, so first we need numpy. So import numpy as np. Then we need the sequential model. So we have to import the sequential model from keras.models. So from keras.models import sequential. We are done. You may also use tensorflow.keras.models, but I'm going to use keras.models. And we also need to import the layers. So from keras.layers import. So first I'm going to import the dense layer, then the flatten layer. I'll explain each and everything. And then for CNN we're going to use the conv2d and a max pooling. Here is the max pooling 2d and a dropout layer. Okay. And to visualize the dataset we have to import the pyplot. So import matplot. Here you go. Import matplot.pyplot as plt. So let's run this. Yeah, we are done. Now it's time to import the dataset. The CIFAR10 dataset is available in Keras. So what I'm going to do is I'm going to import that from keras.datasets. So from keras.datasets import CIFAR10. Okay, and now I'm going to load the dataset using the load data function and I'm going to store the dataset into for list. Okay, so just like this. So train image will contain the training images and train levels will contain the training levels, and here test image will contain the test images and test levels will contain the test levels. And CIFAR10 dot using the load data function, so using the load data function we are going to load the dataset and we are going to store the dataset into this for list. So let's run this. As you can see, the dataset is being downloaded from the URL. So let's print the shape of our training images, right? So print train image dot shape. Let's see the output. So we are reconnected. Okay, as we have changed the runtime type as GPU, so we have to import the packages again. So let's just do that. Done. Let me just import the dataset also. And here I am going to print the shape of training images. Let's run this. So as you can see, it is the 50,000 of training images and 32 by 32 images with 3, that means it is the color depth or color channels, that is RGB. And if we print the shape of test images, so it will look like this, like print test image dot shape. Yeah, so training images has 50,000 of images and test images has 10,000 of images. So now let's visualize the dataset. Okay, so what I'm going to do is I'm going to store all the classes into a list, and I'm going to visualize each images with their labels. Okay, so class names just like this. So airplane. Let's run a loop to print the dataset. Okay, so for I in range 9, sorry for that, in range 9, plot dot im show training image of I. Okay, and plot dot, the x level will be the classes, right? So x level class names, that is class names, and here the training labels. And now plt dot show so here are the images. Okay, so what I'm going to do is I'm going to create a subplot just like this, plot dot subplot +1, and yeah, so here are the images. We can also increase the size also. For that, what I'm going to do is I'm going to increase the fig size just like this, plot dot figure, and the fig size will be say 10 by 10. Okay, and I don't want to show these, these labels. Okay, so plot dot xticks, it will be null, and plot dot yticks, it will also be null. Let's see the output. Okay, much better, right? Let's normalize the dataset, but first I'm going to print the dataset before normalizing. So print training image of, I'm going to print the first one. Okay, so 0. So as you can see, before the normalization, the dataset, the data lies between 0 to 255. Okay, so I'm going to normalize it like this: train image is equal to train image divided by 255, and test image, it will be test image by 255.0. Okay, we're done. Yeah, so remember, the before normalization it was like 59, 62 like this. So what I'm going to do is I'm going to copy it. Okay, and I'm going to print the same thing, the same data after normalization. Okay, so here we go. See the result, see the difference. Okay, so now the values lies between 0 to 1. Now it's time to build the model. So I'm going to initialize the model with sequential. So model equal to sequential, just like this. And now it's time to add the first convolutional layer. So model dot add conv2d, that is like, so the filter size will be say 64, 3 by 3, and 3 by 3 is the kernel size, and the activation will be ReLU activation function. So okay, if you don't know what is ReLU activation function, what is neural network, so please go and watch the previous videos. I have already explained those, so please go and watch those videos. And here we have to specify the input shape for our input. So input shape, so it will be 32 by 32 by 3. You remember the line where we have printed the shape just like this. So 32 by 32 by 3. 3 is the color depth. Okay, so done. And next I'm going to add a max pooling layer like this, max pooling 2D with the size of say 2 by 2. So it will pull the maximum element from the matrix. Okay, and next we are going to add a dropout layer, and this is very much exciting. Okay, so dropout, yeah, so we are adding a dropout layer which will help the model not to overfit. Well, dropout is a great technique used to prevent a model from overfitting. Here, randomly selected neurons will be ignored during training. They will be dropped out randomly. So it is very exciting. And we are going to add another layer of convolutional. So convolutional layer, that is conv2D, and this time we are going to use 128 filters like this. The kernel size will be 3 by 3. The activation will be ReLU, and we don't need to specify the input shape because it is a sequential layer, that means the sequences of layers. So next we are going to add another max pooling layer like this, max pooling with the size of 2 by 2, sorry, 2 by 2, and we're going to add another layer of dropout like this, and we are done with the convolutional. Now we have to add a normal neural network like DINS. Well, remember, the thing is here the data is in 3D format, like 3-dimensional, 32 by 32 by 3, but I am going to fit the model with a single dimensional array, and for that we need a flatten layer. So model.add flatten layer. So flatten layer means it will flatten all the inputs into one dimensional array, and that array will be fitted by the next dense layer. So model.dense layer, the neuron will be 64 and the activation will be ReLU activation function, that is rectified linear unit if you don't know, and model add will be dense layer, and this time it will be specific like 10. Why 10? Because we have only 10 number of classes, remember that. Okay, and this is the output layer. So in output layer the activation will be softmax. Okay, so we are done building the model. So now let's run this. Now it's time to compile the model. How to do it? Don't worry, here we go. That is model.compile. Yeah, just like this. So we have to specify some arguments like optimizer, so it will be the famous Adam optimizer, and then we're going to add the loss function, and that will be sparse, sorry for spelling mistake, sparse, yeah, correct, categorical cross entropy. Now why categorical cross entropy? Because we have multiple classes to identify. Like this, we have 10 classes to identify, right? If we have binary data like cat versus dogs or human versus any like horses, if we have 2 classes, then it will be binary cross entropy. And if we have multiple classes or more than 2 classes, then it will be categorical cross entropy. And while training the model, I am going to track the accuracy score. So the matrix will be in third bracket, it will be accuracy. Okay, so we are done. Let's run this. Yeah, now it's time to fit the model. So model.fit, it is very easy, right? So I'm going to fit with the training images and training levels. For this video, let's go for 10 epochs. So epochs equal to 10. Now here I am going to add the validation data, that is validation data, and it will be the test images and test levels, just like this. And I'm going to store it as history, just like this. And after that I'm going to save the model as model.save, say cifar.h5. Oops. Yeah, so I think we are good to go to train the model. Now let's do it. Let's run the program. Yeah, so the training has been started, and I'll see you once we hit the 10 epochs. Okay, so as you can see, in the training data we have achieved 76% accuracy, and in the test data we have achieved 72% accuracy. Let's plot the result. So plt.plot history and the accuracy, comma, the label will be accuracy. Okay, just like this. And we are also going to plot the validation accuracy also. So plot.history the value accuracy, like this. So the label will be value accuracy, so like this, val accuracy. Now let's print the epoch and accuracy on x level and y level. So plot.x level, so it will be epochs, and in y levels it will be the accuracy. Let's add a limitation to the y, that is y lim will be from 0,5 to 1. So I think we are good to go. So now let's run this program. So here is the graph. So as you can see, the accuracy in blue line and the value validation accuracy in the orange line. And I think our model has performed a great job with only 10 number of epochs. And I hope I was able to teach you how to build a CNN to classify the CIFAR10 dataset. If you have learned something, please like this video. If you don't, give it a dislike. And comment down how can I improve myself to make more and great free videos for you. That's it for today. In the next video, you will see another project or maybe some theory. Please like, share and subscribe to this channel and hit the bell icon to never miss an update. I'll see you in the next video. Until then, enjoy neural network.